So when you say fraction, what comes into your mind, guys? There is a number in the numerator, there is a number in the denominator, right? So a fraction is a quotient of two numbers, no? Normally real numbers. Okay? So for instance, we have A over B. So that is a fraction. Where here, we assume that B is what? Not equal to 0. We call A here numerator. We call B denominator. So this is the fraction that you learned when you were in elementary and perhaps high school also. No? And also you learned that if A is, let's say, less than B, then this fraction A over B is called proper fraction. Here we assume that A and B both positive. Okay, guys? Because if you have, for instance, you might say -4 over 3, and -4 is less than 3, so it doesn't mean it is a proper fraction. So let's focus on positive numerator and positive denominator. Then the ratio is a proper fraction if A is less than B. Okay? If A is greater than B, then A over B is an improper fraction. Again, we assume here that A and B are both positive. Okay? So for instance, if I have 5 over 8, so here, this is what, guys? Proper, no? While 8 over 5, this is improper. Okay? Now, if I have, let's say, a number like this, 4 and 1/5, we call this, when you were in elementary, mixed number. Mixed number. Normally, in college, algebra, we prefer to write your answer in improper fraction form rather than mixed number. Okay, as long as reduced. Although when you were in elementary, so you met this, no? You encountered this thing. Okay, when you take civil service and there are questions about math, especially about fractions, So I think they have problems about mixed number, no? You are going to add mixed number, for instance. If you want to work in a government, you have to review your basic math, okay? So because it's part, usually the reason why many failed in civil service because they find math difficult there. All the basic questions, but to many, it's hard. Get it, guys? Now, the fractions that we will be considering are those fractions that contain letter generally, or letters, not just actually one letter, possible to be more than one letter. Okay, guys? Now, so let's consider a fraction of the form, for instance, P over Q. What can we say about the value? Value of a fraction. Let, oh no, not let. For all P and Q that are elements of the set of real numbers, the following hold. Okay? Number one, given a fraction P over Q, which is equal, for instance, to V, this is true if and only if P is equal to the product of Q and V. Okay, guys? But of course, we assume that Q is not equal to 0 because division by 0 until now is not defined. Clear? Yeah. So for instance, if I have 10 over 5, this is equal to 2 if and only if 10 is equal to what? 5 times 2. Okay? And we know that 10 is equal to 10. Get it, guys? Let's say I have this fraction P over Q. It is equal to a multiplication form P times 1 over Q. Okay? So as long as, of course, Q not equal to 0. Let us consider P over Q, which is equal, for instance, to V. Number one, we say that if P is equal to 0 and Q is not equal to 0, meaning the denominator is not equal to 0, then what do you expect for the quotient? The quotient is equal to 0. Okay, guys? For instance, if I have 4, not 4, 0 over 4, that is equal to 0. If I have 0 over negative 8, that is equal to 0. Okay, guys? If I have 0 over x minus 1, that is equal to 0. provided that x is what? Not equal to 1. Okay? So again, 0 over x minus 1 is equal to 0 for any real number x that is not equal to 1. Okay? So if the numerator is 0, the denominator is not, the quotient is 0. Number 2, if I have, for instance, p not equal to 0 and q is equal to 0, then what do you expect for the quotient? What is not 0 over 0? B is what? Is undefined, meaning it's not a real number. Okay, guys? Not a real number. Not a real number. Okay? So, for instance, if I have 4 over 0, so that is undefined. Or you can say does not exist, no? As a real number. Does not exist. By the way, if you put does not exist, you're not supposed to write equal to 0. Huh? I mean, or equal to 4 over 0. Just say 4 over 0, no equal sign, does not exist. But if it is undefined, it's all right. 4 over 0, we read equal sign as is rather than equal. 4 over 0 is undefined. Get it, guys? Yeah. Number 3. If P is, let's say, equal to 0, and Q also is equal to 0, meaning P and Q are equal to 0, no? Both. Then, what can we say about the quotient? Is still undefined. Okay? B is what? B is undefined. Get it, guys? Okay? So, for instance, if I have 0 over 0, that is undefined. It's not a real number. Okay? Why is it that 0 over 0 is considered not defined? Let's say 0 over 0 is equal, for instance, to V. If and only if what? 0 is equal to 0 times V from what we had in this property. Okay? P over Q is equal to V if and only if P is equal to QV. No, as long as, but here, of course, Q is not equal to 0. Let's say we allow Q to be 0. 0 over 0 is equal to B if and only if 0 is equal to 0 times B. But to get 0 on the left side, so which is equal to the right side, no? 0 times B, what should be the B in order for us to be 0? So B here is what? B is any what? Any real number. No? Am I right, guys? If I plug in any real number to V, will it be equal to 0? Yes, no? So which is not unique? Which is not unique? Okay? Meaning, indeterminate. We cannot determine a unique number that will make it what? 0, no? Okay? So, mathematician prefers not to define what? V. Therefore, mathematicians prepare, yan, because they want a unique quotient. Am I right, guys? So mathematicians prefer to define zero over zero to be what? To be not a real number. Okay? Because it's not unique. As I said, I can choose any V so that when I multiply it to zero, I will get zero. Get it, guys? Children? So again, what is zero over zero? It's still undefined, huh? Then, don't put infinity, huh? O for 4 over 0, for instance, any division by 0 is not allowed. In other words, division by 0 is not allowed. Okay? Division by 0 is not allowed. Clear, children? Guys? Okay. So, we now move to our main concern. Our main concern on fractions about algebraic fractions, meaning containing variables generally. Okay, guys? So we have algebraic fraction. What is an algebraic fraction, guys? Anyone? Do you have any idea? When you say algebraic fraction, it is an expression which is a quotient of what? Of two algebraic expressions. Okay, guys? Meaning, the numerator is an algebraic expression. The denominator is also an algebraic expression. For instance, I can have 5 over 3 negative 2x over z cubed w. I can have also x squared plus y squared all over x plus y plus 3. And even containing radical, no? Square root of x plus square root of y over x to the 1/2 plus y to the 2/3. Okay? So these are examples of algebraic fractions. But our concern about algebraic fractions, fractions whose numerator polynomial, whose denominator is also a polynomial. Get it, guys? So we call that rational expression. Rational expression. What is a rational expression? A rational expression is an algebraic fraction, an algebraic fraction whose numerator and denominator are what? Are both polynomials. Okay? Get it, children? Let's say I have -7 over -8 for mn all over, o kaya for mn over 5m squared and cubed. A squared plus 2b plus 3 all over a minus b. Okay, so these are examples of rational expressions. Notice that numerator in each is a polynomial, denominator in each of these given fractions, polynomial also. Okay? Get it, guys? Now, how to determine valid values for the letters involved in a rational expression. So we call that the domain of a rational expression. Because not all numbers, real numbers, you can substitute to the variables involved in a rational expression. No? You should know the restriction. So domain of a rational expression. What is the domain, guys, of a rational expression? So it is the set of values of the variables involved. Okay, guys? That will make what? That will make the expression a real number, or that will make the rational expression a real number. Okay? For instance, if you have 4 over m, so what's the domain, guys? What do you think? The domain of this rational expression is what? Any real number as long as what? Not equal to what? Guys, m is a real number such that not equal to 0. Okay, guys?
Yes, po.
If I have, for instance, x over x squared minus 4. So what's the domain? Any real number as long as not equal to what? all x, understood that it is a real number, huh? That x, such that x not equal to plus minus 2. Okay? Any real number as long as x not equal to 2, not equal to negative 2. Get it, guys? If I have, for instance, x squared minus 3xy plus 15 y squared. So all over x minus y. So domain set of all xy, as long as of course they are real numbers, such that x is not equal to y. Okay? So if you assign value to x, value to y, as they should not be equal. Otherwise, you will get division by 0. Clear? Guys? Okay? There are properties for fractions, no? That you should recall. What are those properties? Of course, aside from properties that you had when you were in elementary, no? These are important properties. So again, in working with fractions, so it is important to know and understand the basic properties that you can associate with them, no? So number one, fundamental principle of fractions. Sometimes you know how to do it, but you do not know that it is called fundamental principle of fractions. So what is said about this? The value of the fraction, the value of any fraction, does not change. If the numerator and denominator are both multiplied by what? By the same non-zero number. Okay? As long as your multiplier to the numerator and denominator non-zero. Okay? So in mathematical form, we say that P over Q is equal to, so let's say I want to multiply P and Q by what? I want to multiply P by M. I have to multiply also Q by M. So there will be no change in the value. Get it, guys? Or you alternatively, you can also say that given P over Q, I can divide instead of multiplying by M. And dividing by M means multiplying by 1 over M, both the P and Q. So P divided by M over Q Q divided by M. This is very useful, this procedure, when reducing a fraction to its lowest terms. Get it, guys? Let's say I have 6/10. So if I want to reduce that fraction, so what will be my divisor to both the numerator and denominator? I have to divide the numerator by 2, no? If I have 6/10, so to get 3, divide 10 by 2 to get 5. So we will have 3/5. Okay? So very useful in simplifying. In the same way, useful also if you want to produce a fraction with a desired denominator, for instance. If I have 3 halves, I want to make the denominator 8, I have to multiply both the numerator and denominator by 4. Okay? So again, if I have 3 halves, let's say I have 3 halves. So I want to come up with a denominator that is 8. I have to multiply both the numerator and denominator by what? By 4. As long as not 0, huh? So here, we assume that that M is not what? Not equal to 0. Okay? Get it, guys? So what is now my new fraction? So this is equal to 12/8. So 3/2 is equivalent or has the same value with 12/8. Okay? If I have negative 10 over, let's say, 18, and I want to reduce this, so I have to divide negative 10 by what? By, let's say, 2, no? I have to divide also the denominator by 2 to get what fraction now? Negative 5/9. So that is the reduced form of negative 10/18. So that's the use of fundamental principle of fractions. The second property that you have to recall about signs of fractions. Signs of fractions. There are 3 signs associated with a fraction. What are they, guys? So first we have the sign of the numerator. Numerator can be positive, can be negative, no? As long as it is not 0. We have the sign of the denominator, same thing with the denominator, can be negative, can be positive. Okay? And possible, also, you look at the sign of the fraction itself. Okay? If positive, normally understood if there is no negative, it is positive. But if it is negative, it should be indicated. Okay? And this is the trick here, no? So if 2 of the signs of a fraction are changed, what's the effect? The value of the fraction, what will happen to the value of the fraction, guys? Does not change, no? Okay, let's say I have 4 over -3. What is the sign of the numerator? Positive. What is the sign of the denominator? Negative. What is the sign preceding the fraction itself? Not the totality, but the one that is in front of the fraction. Positive. Okay? Although the value of the fraction is what? Is a negative in totality. Now, if I'm going to, let's say, change two of the signs, let's say, I will change the sign of the numerator into -4. Change the sign of the denominator into +3. How many signs did I change? 2 signs. So there is no what? No change in the value of the fraction. What about if the one that I will change, the numerator, and also the sign of the fraction itself? Remember, preceding the numerator, I mean the fraction, we have positive, no? And then I'm going to make it negative, so I will have negative of -4 over -3. I copied -3, so I changed the sign in the numerator and the sign of the fraction itself. Still same value with the original. Okay, guys? Or I can change the sign of the fraction itself from negative, I mean positive to negative, the denominator into positive, the numerator retained. Still the same value. How many signs did I change in every fraction that I had? So 2 signs only. That's why all these resulting fractions are what? Have the same value. Now get it, children? Guys? Children?
Yes, sir.
Okay. And then the last one, number 3, we have property equivalent fractions. When do we say that 2 fractions are equivalent? Meaning having the same value, although different forms, no? So we have equivalent fractions. The value are equal. Okay, 2 fractions are equivalent if they represent the same numeral or numerical value. Again, 2 fractions are said to be equivalent if they represent the same numerical value. Okay, so it means in terms of mathematical form, A over B is equal to C over D if and only if their cross products A times D is equal to C times what? Times B. Okay, guys? Of course, we assume here that A and B are what, guys? not equal to what? They are not both equal to 0. Okay? The denominator. A and D, I mean. A and D. Okay? Guys? No. Not A and D. Ano ba yung denominator ko, guys? Ano yung denominator ko? B and D. Not equal to 0. Clear, children? Guys, is that clear? Children? Because my denominators B and D. So let's say 4 over -5. This is equal to 12 over -15. Why is it that they are equal? Because what, guys? Because if I'm going to get 4 times -15, that is equal to what? -5 times 12. Am I right, guys? Guys? Check
Yes
na?
po, sir.
If I have, let's say, x minus 2y all over 4xy squared. So this is equal to 2x y minus 4y squared all over 8xy cubed. Yan. So, why? Why are they equal? If I'm going to get their cross products, so equal, no? So we have here, let's check. 8xy cubed times here, we get 8x squared y cubed minus 16 xy to the 4th. And then we have that is equal to 8x squared y cubed minus 16xy to the 4th. Right? Check, no? Of course, we assume that what? Where x, y should not be equal to 0. Okay? With that assumption. Is that clear? So let's now move on to simplification of fractions. Or in particular, rational expressions. So normally, when you were in elementary, it's called reduction to lowest terms, na? Guys? Get it, guys?
Yes po, sir.
Now, when do we say that two fractions are in simplest form, guys? So when do we say that a fraction is in simplest form? Children, anyone? A fraction,
Kapag hindi mo na po kayang i-divide, so
na kayang i-divide. A fraction is said to be in simplest form What again the other term for simplest form, guys? Lowest terms. Lowest terms. If the numerator and denominator are what? Guys, denominator have no common factors, have no common factors except what?
1 po.
Except plus or minus 1. Okay? Is that clear? So let's say the remaining common factors to the numerator and denominator, 1 or negative 1. So you can no longer simplify that. Get it, guys?
Yes po, sir.
So how to reduce fractions to lowest terms? So the following examples will illustrate. No? Factoring is very important when you are simplifying fractions. Okay? Yeah. So reduce to lowest terms or simplify the following fractions. Reduce to lowest terms. Assume that no denominators are 0, okay? With that assumption. Get it, guys? So let's have so again, assume that no denominator is 0, meaning no variable will have a value that will make the denominator 0. Is that clear, guys? Okay, number 1. If I have 15 xy cubed all over 42 x to the 4th y to the 6. So to simplify this, we have to what? To cancel common, no? Between 15 and 4, is there any common? I mean 15 and 42, guys? 15 is factorable into what, guys?
5 and 3 po.
5 and 3. What about the constant in the denominator? 42 is what?
3 and 14 po.
3 times 14. Okay? So does everybody agree with that, guys? So what about for letters? So we have x and then y cubed. In the denominator, x to the 4th has x, no? Getting x times x to the 4th. What about y to the 6? Can be written y cubed times y cubed, no? Am I right? So I can now cancel out x here, y cubed, and then the constant 3.
Sir,
So
excuse me po.
out.
Sir,
Okay? Yes?
sir, sorry po. Na-duplicate po ata yung x for the
Oo nga.
denominator.
So, hindi, I not duplicate. I got a wrong exponent for the other one. Should be x cubed. Okay now? Remember, x to the 4th can be written x times x cubed, right? So I can now cancel out 3x and y cubed. No? Because they are all common. What is left, guys, in the numerator? Simply what?
5.
5, no? What about in the denominator?
14x cubed y cubed.
14x cubed y cubed. So this is the simplified form. Okay? Number 2. If I have 4x squared minus y squared all over 2xy minus xy. So the numerator is factorable into what? That is difference of two squares, right? X plus y times 2 in the x, no? 2x plus y. What is the other factor? 2x minus y. Difference of two squares. Am I right? Then what about in the denominator? There is a common, no? What is common, guys? This is supposed to be, I got a mistake in the denominator. 2x squared. 2x squared minus xy. So what is common? X, no? So we're left with 2x minus y as the other factor in the denominator. Can I now apply cancellation here, guys? Yes,
po.
no? Of course, we assume that 2x is not equal to y during the process of cancellation. Okay? So getting 2x plus y all over x. Again, when I canceled out 2x minus y from the numerator and denominator, we assume that 2x is not equal to y because our condition in the instruction, we assume that no value of the denominator or no value of the variable will have a denominator equal to 0, no? Okay? What about number 3? If I have 4x plus 12 all over 2x plus 7 times x and then added to this 3. Okay, guys? Yeah. What is the numerator, guys? Can be factored into what? 4 and what is the other factor?
X plus
X
3
plus
po.
3. Can I cancel x plus 3? Can I cancel it out with x plus 3 in the denominator?
Yes po.
No. You can't cancel. Why is it that we cannot cancel it? Say people. Because x plus 3 is not a factor. So the denominator contains two terms. The first term is a product of a binomial and a monomial. The second term is a constant 3. Did you get that, guys? Guys.
Yes po.
So you have to multiply first x inside, getting 2x squared plus what? 7x. You're going to multiply in the expression inside just the x, not included the 3. Because it's not part to be multiplied to 2x plus 7. It is separated. Clear, children? Guys?
Yes po, sir.
That's the time you're going to try to factor the denominator. If still factorable into what? Into factors with x plus 3 as one of the factors. Is x plus 3 one of the factors here? Let's try. X plus 3. If I have x plus 3, then I will get here 2x plus what? Plus 1, am I right? Middle terms, 6x plus 1x. So 7x, no? Then we have 2x squared. Last term, 3 times 1, so 3. Okay, guys? So possible, no? Let's say you can factor the denominator into what? Into x plus 3 to x plus 1, meaning does not contain x plus 3 as a factor. No need to factor. It means it's already in simplest form. Let's say you have factored it, but no x plus 3 is useless. It's useless. Okay, guys? So, but if you have factored it, it's all right. But you will not able to simplify actually. 4 over 2x plus 1. Take note that this fraction, 4 over 2x plus 1, is equal to this original fraction, provided your x is not equal to -3. Because when we cancel x plus 3, when x is -3, it will become 0. So with that assumption, so these two are equal. This original and the new one. Okay? Number 4. What about if I have 2x minus 3, and then the denominator, I have 2x, x plus 5, 2x, x plus 5, minus 3, then x plus 5. Okay, guys? Yan. 2x minus 3, there is 2x, then there is -3 here. But it's not a factor, that 2x and the -3 here. Huh? So what we do, we try to factor out first the denominator. What is common, guys? X plus 5. Then, for the first term here, what is left? Simply 2x. What about here? -3. Oh, is there a 2x minus 3 factor in the numerator and in the denominator? Yes, no? So I can apply cancellation here. So this is canceled out with this. Okay? So what is now the simplest form? 1 over x plus 5. Oh, is that clear, children? What about if I have 8ab plus 4b quantity squared, 4b squared, quantity squared, all over what's the denominator? 8a cubed b plus b to the 4th. Okay? First, let's do factoring inside parentheses. So inside parentheses, there is a common b, no? Then, what is the remaining? There is also a common 4. What is left inside? 2a. What about here? Just b, no? Am I correct, children? And the whole thing is raised to 2. I did a factoring inside. And then in the denominator, common is what? What is common in the denominator, children? Guys. Huh? What is common?
B.
B, no? Just the B. What is left? For the first term, or in the first term, 8a cubed, right? Second term, b cubed. Okay? But I think this is still factorable, no? The denominator. Can you give me the factored form of that? How do you identify 8a cubed plus b cubed? That is what, guys? Sum of 2 cubes, right? So b, what are the factors here? 2a cube root of a cubed plus b cube root of b cubed. The remaining factor is a trinomial. Square the first minus the product. So that is 2ab plus the square of the second, b squared, no? Okay, children? What about the numerator? I can say that it is equal to what? 4 squared, that is 16. Then, b squared, am I right? Or the remaining factor is what? 2a plus b. And then, 2a plus b or 2a plus b quantity squared. So from here, I can cancel this out. 1b, no? So minus 1 in the exponent here. And then 2a plus b, because that is a factor also canceled out with this. Am I right, guys? What is now the final answer? Guys, in the denominator, 4a squared minus 2ab plus b squared. What about in the numerator, children?
16b
16b
times 2a plus b.
2a plus b. No need to multiply 16b inside. You can leave your answer in factored form. But if you want, it's all right. Let's say it's a multiple choice. You just determine which one is in the choices, the expanded or the factored form. Okay? Number 6. What about number 6? For number 6, we have 2a squared minus 16b times a, then plus 30b squared all over 2a squared minus 13ab plus 15b squared. Okay, what about this? The numerator. Is the numerator factorable? So if it is factorable by trial and error, no? Possible factors of 2 to 1. What about 30? By the way, there is a common, no? Let's factor it out first. What is common, guys, in the numerator?
2
2,
po.
no? Then a squared minus 8ab plus 15b squared all over. Is there a common in the denominator? There's no common anymore, no? So that is factorable into what? Guys, let's have a scratch here. 2, 1. I want to get negative 30, no? So this is 5, 3. So 10, 3. Then add to get 13. But I want negative. So this is negative, negative. No? Para sum is negative. So meaning this negative 3, negative 5. So that the product is positive 15. Okay, guys? So 2a minus 3b. Then a plus 5b. Okay? What about a squared minus 8ab plus 15b squared? What is the factored form of that?
Quantity
Guys.
of a minus 3b po multiplied by quantity of a minus 5b.
So a plus 5b, then the other factor is a plus minus yata yun.
Minus po, sir. Sorry po. A minus 3b times a minus 5b po.
Teka ha, mali ako ng sign dito. Minus 5b here. Okay, so 2 times a minus 5b, a minus 3b. Am I right now?
Opo, sir.
Okay. So this is common, no? We can get rid of that. What is left now? 2 times A minus, mali ang na-cancel ko. Wait a minute. So, it's this one, huh? I'm excited. We have 2 times A minus 3B. What about in the denominator? Simply 2A minus 3B. Can we cancel something? Is there something that we can still cancel out? No more, no? Okay, children. The last one. So this is the last one, number 7, for simplification of fraction. AC plus 2AB plus BC, then plus 2B squared. All over 2AC minus AD plus 2BC minus BD. Okay? I think this is factorable, both the numerator and denominator, in case by grouping, no? Which do you think are in the same groups? Let's try A, no? Factor out from the first two. We get what? C plus B, right? What about in the second group? Factor out B, we get C plus, I think I missed the 2 here. Wait a minute. I slipped this one, this value, 2B. And then plus B, then we have C plus 2B. No? Am I correct, children? What about here? Let's try A, then 2C minus D. And then for the last two, we have B again, then 2C minus D. There is a common in the numerator, no? That is C plus 2B. So what is left in the first group? In the numerator, A. Second group, B. All over. In the denominator, common is 2C minus D. And then A plus B also, no? The remaining here. So I can get rid of this now so that I have only C plus 2B or 2B plus C. I just arrange in alphabetical order. And then 2C minus D. Get it, guys? That's it. Okay, children? Any question with that? So this time we have operations on rational expressions. We can add them, we can subtract, we can multiply, we can divide. Get it, guys? Children? Now, you review finding LCM and greatest common, greatest common and least common multiple. Okay? Because very important in performing operations on rational expressions. Okay, so now let's begin with addition. Letter A, addition. of rational expressions. What are the principles? Let's say I have A over B plus, no. We have same denominator, no? Same denominator. If you have same denominator, let's say A over C plus B over C. All you have to do is to add the numerators and divide by what? The common denominator. And of course, you need to simplify in case possible. Clear? What about different denominators, meaning distinct, no? Different denominators. If you have different denominators, you have to what, guys? You get the LCD, no? A over B plus C over D. So that is equal to, what's the LCD, guys? BD in this case, no? BD divided by B, that is D times A, we get AD. Plus BD divided by D, so that is B times C, so we have BC. Actually, there is a pattern that you can have here. Okay, guys? So you do this, no? You multiply A with what? With the D. And then add it to the product of B and C. And then multiply the B and the D. Okay? Get it, guys? Okay now? So what about if you have subtraction? Actually similar, no? All you have to do is to what? To make this difference, no? So we have subtraction of rational expressions. Okay? Now, by the way, in case it's already time, you can leave, but still I will continue to finish the recording. No need to ask permission. You can leave anytime you want. I will be continuing the discussion for recording purposes. Okay, guys? So I will just copy this and then just change to subtraction. So instead of addition, subtraction. Okay, guys? That's it. Okay? So let's start doing this. Of course, we assume that C is not 0 here. We assume that B, D not equal to 0. C here is not equal to 0. B, D here not equal to 0. Yeah. We assume that. Okay? So let's do. Let's say we're given the following. Perform the indicated operations. Number 1, we have 8 over 9 plus 2 over 9, then minus 4 over 9. So combination of subtraction, addition, no? But having the same denominator. So you just combine the numerator and denominator. I mean the numerators, no? A plus 2 minus 4. Then all over the common denominator because same denominators, no? So simplifying, we get 10 minus 4, that is 6 over 9. Simplifying further, because this can be reduced into what? Divide by 3, 2. Divide by 3, so 2/3. Get it, guys? What about if I have this one? We have 7x plus 1 all over 5x minus 1. Then plus 1 minus 17x all over 5x minus 1. So same denominator, no? So all we have to do is to combine the numerator at 1. So we have 7x plus 1 minus 1, plus 1 minus 17x. Copy the common denominator. And this is equal to what, guys? 7x minus 17x is negative 10x. 1 plus 1 is positive 2. Correct, children? But I can still simplify this, no? Factoring out negative 2 to get the remaining factor, 5x, then minus 1, huh? All over 5x minus 1. And getting simply negative 2. Is that clear, guys? So this is canceled out. Of course, we assume that no denominator is 0, no? Assume no denominator is 0. So with that assumption,
Sir, can I
yes,
ask po, kailan po ipopose yung activity po?
within this week,
Okay po. Thank you
there
po.
will be a time limit for that because that is just an activity containing just 5 numbers, multiple choice. Okay? Just to make
Okay
up
po.
with the problems in quiz 1 about fractions. Okay?
About ano lang po siya, sir? Rational expressions?
Yes.
Okay po.
About fractions. Because there were questions in fractions and I was not able to keep focus on this in the last, what you call this, discussions we had. Okay? Number 3. (5r minus 9 all over r minus 2s, r minus 2s. And then plus 6r plus 4 all over 2rs minus r squared minus 7r minus 5 all over r squared minus 2rs. Okay? So let's check the denominator, guys. First denominator, if you're going to second, if I'm going to factor out negative r, what will I get here, guys? Negative r is factored out. So r minus 2s, right? What about here? If I'm going to factor out r, I will get what, guys? R minus 2s2, no? Actually, almost the same denominator, no? Except for negative here. But this negative can be what? I can rewrite the second fraction so that the negative is what? Will not be part in the denominator. I can change the sign of what? Of the denominator. From negative, I'm going to make it positive so that there is no change in the value. Remember, you have to change two signs. So I'm going to change the sign of the fraction itself. So minus now. And no more negative in the denominator. Copy the numerator. How many signs did I change, guys? Guys, how many in the second fraction? Just two, no? The denominator in the third is factorable into r minus 2s. Get it, children? Okay, so we now have LCD is r minus 2s, right? Let's copy the numerators, then combine them, no? So minus 6r minus 4, minus 6r minus 4, minus 7r plus 5. Get it, guys? Then here in the denominator, the common now, r minus 2s. So simplifying the numerator, we get 5r, negative 6r, negative 1r, negative 7r, negative 8r. Okay? And then 9, negative 9, negative 4, negative 13, plus 5, negative 8. Am I correct, children? Right? So again,
Yes po.
negative 8. So all over r minus 2s. Oh, are there any quantities we can cancel? If I'm going to factor this out, will I produce r minus 2s? No, no. So this is already the answer. Alternatively, you can factor out a negative 8, and the negative put it before the fraction as your final answer if you just want. So the answer in factored form is r 8, negative 8, r plus 1, then denominator r minus 2s. Okay? Well, that's it. Number 4. So we have 8 over 9 plus 2 over 3 minus 4 over 18. Oh, here, they are different denominators. So what's the LCD, guys? Children, what do you think? What is the LCD? Is it 18? 18, huh?
Yes po, sir. Apo.
So I'm going to divide this 18 by 9. 18 divided by 9, 2 times 8. So 2 times 8 plus 18 divided by 3, 6 times 2, 12. Okay? Minus 18 divided by 18, 1 times negative 4, so minus 4. All over 18. So that is 16 plus 8, no? All over 18, and then 24 over 18. Can I still simplify this? Yes, divide by what? Divide by 3, no?
6 po.
Divide by 3 or 6? Divide by 6? Divide by 6? What is that, guys?
4/3 po.
So divide by 6, 4. Divide by 6, 3. So 4/3. Okay, number 5. If I have 3x over 3x plus 2y, then minus 4y all over 3x, 2x, it's not 3x, 2x minus 3y. Are the denominators the same? No. So need LCD. What's the LCD? 3x plus 2y, 2x minus 3y, right? That's the LCD. So this fraction, so we start with this LCD divided by the denominator. So canceled out 3x plus 2y. So we get 2x minus 3y times 3x. So 3x times 2x minus 3y. Then minus 4y times, what's the remaining? So 2x minus 3y is canceled. So negative 4y times 3x plus 2y. Okay, children? Or yung shortcut, 3x times this minus 3x plus 2y times negative 4y all over the LCD. LCD is 3x plus 2y, 2x minus 3y. No need to multiply this, no? No need to expand. You can leave your answer in factored form as long as there is no common anymore. Okay, children? Guys? They don't want to talk.
Yes po, sir. Yes po.
6x squared minus 9xy minus 3 times 4, 12, then xy minus 8y squared. The denominator, 3x plus 2y, 2x minus 3y. Let's simplify that numerator. Let's simplify the numerator. What's the simplified form of the numerator, guys? What is that equal to? I will write here. There is still enough space. 6x squared minus 21 xy minus 8y squared. No common, no? All over. What's the LCD? This, just copy there. Get it, guys? What is the factored form of the numerator? Is it factorable, guys? Guys, is it factorable?
Yes po.
What's the factored form? So will it have, so let's say 3, 2, and then 8 is 4, 2, no? There is common here. So cannot be 4, 2. So this is 2, 4. No? Even though you factor it, you can factor it, but it will not give you 3x plus 2y, I think 2x minus 3y. No, guys? Am I correct, guys? So if I have, for instance, 3x plus 2y, what is the remaining here? 2x. Will I get the middle term, guys? Wala, no? Hindi. Okay? What about if I have 2x? Because even you can factor it out, You can factor this, but I mean, you can express this in factor form, but no common here, useless. Okay? What about this? If this is 3x, and then it's supposed to be plus, but if there is no 3 factor for 8, so that's it. No? Okay, it's all right not to factor that. Just copy 3x squared minus 21xy minus 8y squared. Okay, guys? Get it, children? You can leave your answer as is. That's it. That's the final answer. Number 6. We have two over x plus 3, x plus 1. The second fraction, the denominator is x plus 1, x minus 2. Numerator is 5. The third fraction is, the denominator is x plus 3, x minus 2. Okay? The numerator is 3. What about here? What's the LCD, guys? Children, what's the LCD? X plus 3, x plus 1, x minus 2. Am I correct, guys? Children?
Yes, sir.
So first, let's simplify, let's divide that LCD with its denominator, no? And its result to be multiplied to the respective numerator. X plus 3, x plus 1, x minus 2, when divided by this, so canceled out these two factors. So we're left with 2 times x minus 2. Second one, 5 times. So we have x plus 3 remaining, no? When this is divided by the denominator here. And then for the third one, minus 3 divided by here. So canceled out x plus 3, x minus 2. We are left with x minus 1. Get it, guys? Children? Okay. What is the denominator? I will copy this denominator, this LCD. That is the denominator. Just put it there. See, our blackboard is high-tech. Yes. Do you have any question?
Po, dapat x plus 1 po yun sa may numerator.
Oh, ayan o. X plus nga.
Thank you. Thank you.
It's x plus 1 really. Thank you. Joke lang. So, equals. Multiply 2x minus 4 plus 5x plus 15 minus 3x minus 3, no? Minus 3. Okay? Yan. All over, the fraction is very long. I mean the fractional bar. Or same LCD, no? Same denominator, I mean. Combine. What is the result, children? 2x, 5x. Guys, minus 3x. Is it 4x? Or
Opo. 4x po.
4x, no? What about, wait a minute, let's put the denominator. When you write a fraction, be sure you write first in the part of a fraction, meaning in the numerator or denominator, whichever will contain more terms or more expressions, no? More expression, for instance, here. So you start with the denominator so that your numerator, for instance, is at the middle, no? So getting 4, no? 4x What about the constant? 11. 11 minus 3. Guys, 8. Am I right? If I factor out 2, what is left? I mean 4. X plus 2. Ay, sayang. It's plus, no? Not minus. Okay, guys? So it's we can no longer simplify it further. Oh, that's it. Oh, we tried to factor it because we are hoping that something will be cancelled. But if you think nothing can be cancelled, no need to factor. Clear, children? Guys? Guys?
Opo, sir. Clear po.
Yeah. As in crystal?
Opo.
Okay. Number 7, the last one for addition and subtraction. Then we will proceed to multiplication. So again, I'll be continuing so that the recording will be complete. But if you want to go, then go ahead. I think I need this one. 2 over a squared minus 3ab minus 3ab plus 2b squared. Second fraction minus 4 all over a squared minus 4b squared. Third fraction, I think it will be a long solution. A squared plus ab then minus 2b squared. Okay, guys? Numerator 3. Okay. I think it's still minus here. What's our LCD, guys? We have to factor first, no? Let's factor the denominator. Is it factorable, guys? A minus 2, A minus 2, 2B, no? A minus B. Am I correct, guys? What about in the second fraction? It is A plus 2B, A minus 2B. Get it, children? What about in the last fraction? I think I need to put it here. What's that, guys? A minus 2B, A plus B, no? Negative 2. Oh, no. It's not. It is plus here, minus here. Let's check again. Okay, now, no? So this is 3. Okay, guys? Can we now get the LCD? What is the LCD, guys? A minus 2B. What else? A minus B. What else? Dami yata. Ano pang LCD, guys? I mean, ang factor.
Plus 2B.
A plus 2B. Meron pa? Wala na, no?
Wala na po.
Okay. We have 3 factors in the LCD. I was thinking 4. Too much. Do not be given like that. In engineering, perhaps, it's just a requirement, I think, for Pol Sci, no? To have algebra. Do you like algebra, guys? You don't like?
Hindi po.
Why don't you like algebra?
Mahirap po, sir.
Hirap. Especially in UP. In UP really, I don't know. I don't really understand why math is really difficult in UP, no? So, but you want it to be
Sana
like
po, sir, madali lang po yung activity.
activity. You don't expect that because you're in UP. The reason why you want to be in UP because you want to be recognized to be what? To be like that. So that's the difference, guys. Get it, guys? That's the consequences of being in UP. Of course, if you want to have easy math, you're not supposed to be here. That's the, what you call this? The trademark of UP, no? Okay? Even when I was in college or I was in high school, that was my thinking. Oh, UP. I don't want to study in UP because it would exhaust my brain. Okay? Children?
Sir, kaya naman po.
Okay, so I know you can do it. So that's why I'm trying to help you teach the best I can. No, but to request for me easy one, I don't expect. There will be easy, there will be difficult. Okay, children. What about the numerator? 2 times what? What is left? 2a plus 2b, right? Minus, what is the numerator here for, no? Minus 4 times a plus 2b, a minus 2b, we get rid of them. A plus 2b, a minus 2b. So we are left with a minus b. What about the last one? 3. What is left, guys? Guys. A what? For the last one. So here. A minus 2b, okay? You know Corina Sanchez? She studied in UP also. You know where her Waterloo? According to her, when she was in UP, she was really, really upset with this algebra. So she got what? Barely passing only in algebra, almost failing. So, okay. So according to him, really difficult algebra.
Sir, huwag ka naman ganyan, sir.
That was according to Corina Sanchez. You're lucky because the test multiple choice. Do you know that if it is face-to-face, we don't do this? Get it, guys? There is part of multiple choice, but it's not about multiple choice. You will be given problem solving like this. You will really be solving, showing solution. Okay? So you're lucky it's not face-to-face. So 2AB, I mean 2A plus 4B. But I know you can do that. Meron pa nga kayong, I think, logic eh. Math logic. Yung about if then, what you call this? Or and. Yan. Plus 6B. Ay, control C. Ay, I have to, wait a minute. Ano ba yan? Mali. I have to copy this. This is what I want to copy. So that I'm not going to write anymore. Yan. So 2A minus 4A minus 3A. That is negative what, guys? Children. Negative, guys. You participate so that
Negative
you know.
5A po.
Negative 5A. Negative 5A. What about the B?
Positive 14B.
positive 14b. Is there something that I can cancel? Guys?
Wala na po.
La. Okay, that's it. See? Very easy. Okay, let's now move to multiplication and division. See, multiplication. Actually, after this, on Tuesday, we will be discussing equations. Then mga word problems. Lalo na yung mga word problems. You will love them. Let's say I have A over B. You multiply it with C over D. Okay? All you have to do is to multiply the numerator, multiply the denominator, and then cancel common factors in case there are. Get it, guys? Of course, we assume that B, D not equal to 0. Get it, children? What about division? If you are dividing a fraction or a rational expression by another rational expression, you convert to multiplication by taking the reciprocal of the divisor, then multiply it to the dividend. Okay, guys? So if I have, for instance, A over B divided by C over D, okay, and this is equal to what, guys? A over B multiply to the reciprocal. Get it, guys? Or multiplicative inverse. So, where here, ano ang ating condition, guys? Dapat ang B, ang D, ang C, naging denominator ng C, they are not all equal to 0. I mean, any of these cannot be 0. Okay, guys? Let us have examples. Perform the indicated operations, assuming none of the denominator is 0. Okay? Assume that no denominator what does this condition mean, guys? Children, what does this mean? No variable in the denominator will have a value that will make the denominator 0. That's the assumption. Okay? Not La Concordia, not St. Paul. Ano ang school? Guys, assumption. Yan ang assumption. Parang pang girls yata. Yan na. Guys? Children? Ayaw nila sumagot. Start tayo sa simple. 5 over 3 to recall. Ito mga ganito dapat marunong kayo ha. Sa civil service, meron yan. So that you can work in Supreme Court, Department of Justice in the future. Di ba pag policy, normally you will be in the future going to enroll in law. Am I right? Some of you perhaps na? Right, guys? O kaya yung iba sa inyo, magiging politician. Na? Times 27 over. Kaya lang pag politician, tempting yan eh. Even you are a good person, but because of the situation, you will be eaten up by what? By the system na? Am I right, guys? Even though you do not want, but you will tolerate others to do. Because that's the system there. And you cannot what? You cannot, what you call this? How will I say it? You cannot say no, no? Or possible you do not want to do, but others do, and then you just tolerate it. Okay? Oh, what about this, guys? 3 times 9 times negative 21 ang denominator, no? Ang numerator, 5. Express niyo yan sa factored form hanggat maaari. Wala namang common ang 4, di ba, sa ilalim? Wala, no? Ang 27 meron. Anong factors ng 27, guys?
3 and 9 po.
3 and 9. So, what about, may 3 na rito, may 9. Ang 27, tsaka 3, no? Am I correct? Ano pwedeng i-cancel out?
3 and 9 lang po.
Yan. Oh, what is now the final answer? Negative, negative ang denominator. Negative 20, negative ang numerator. Negative ang denominator. So positive, no? Am I right, guys?
Yes po.
Yan. The simplest form. Yan. Okay, number 2. What about containing letters? We have x squared minus 16y squared all over. Yan. Three xy divided by sorry 9xy not 9xy, it is xy minus 4y squared. Okay. If you're dividing, what do we do, guys? What are we going to do? And at the same time, factor, huh? Is it factorable? Yes. So that you can easily cancel things that are common. X plus 4y, x minus 4y. All over, guys. 3xy, no? You are going to multiply it with the reciprocal of this 1 over. But this is factorable into y x minus 4y. Correct, children? I can now cancel out this. Yan. Get it, children? What is now the final answer? Guys.
X plus 4y over
All over 3x y squared. Can we cancel x or y here? No, because x plus, not times. Okay? That's it. Is that clear? You can cancel because in the denominator, 3xy squared are all factors, but in the numerator, x and y are not. Okay? Number 3, we have 4a squared, 4a squared over 9 . A is cubed plus 3A squared plus A, then divided by, again, 2 minus 6A all over 27 A cubed minus 1. Oh, what about these children of the Philippines? Hindi kumukuha ng LCD if multiplication and division of fractions, ha? Oh, first one, factorable into what? Guys, A, 9A squared plus 3A plus 1, right? Numerator as is, retained. Then times what? Reciprocal. But you need to factor at the same time, okay? Multiply by the reciprocal. What is the factored form of 2 minus 6A? It will be in the denominator now. And factors of 27A cubed minus 1. It is in the numerator. That is difference of 2 cubes. 3A minus 1. We have 9A squared plus 3A plus 1. Look at that. Same with the factor here, no? And in the numerator, which is now in the denominator, because this is now multiplication, factor out negative 2, we get 3A minus 1. Am I correct, children? I can now cancel this. 1A is canceled, no? So remaining A, no? 2 minus 1 is 1. So there is still a remaining A. 4 and negative 2. There is 2 here, no? And then there is negative. Okay? 3A minus 1 canceled out here. And then this one. Almost everything disappeared. What's the final answer, children? Negative, no? Kasi this is negative. Negative 2A. Simply negative 2A, children. Guys. Okay. Are there still people here? Number 3. What number are we now? 4. Number 4. What about this? We have A, I2 times A squared plus 1. A squared over A squared plus 1 times. So times I have here 4A to the 4th. 4A to the 4th plus 4A squared. In the denominator, we have 9A cubed plus 3A squared plus A this is divided by we have here A what's that? 3A minus 3A. 9A squared. Nine A squared minus 6A plus 1 all over 27 A cubed minus 1. What about this? First, we copy 2 over a squared plus 1 times. So the denominator inside here is factorable into a 9a squared plus 3a, no? Plus 1. The numerator into 4a squared, then a squared plus 1, right? So I can now remove brackets, no? Because I'm now going to convert this to multiplication. So everything is now multiplication. But I have to take the reciprocal. Oh, what is the reciprocal? 27a cubed minus 1 all over 9a squared minus 6a plus 1. But 27a cubed minus 1 is factorable into, so that is difference of two squares, 3a minus 1, then 9a squared minus, plus, no? 3a plus 1. The new denominator, ito na, dito na siya. So it is factorable into 3a minus 1, 3a minus 1. Am I correct, guys? Or 3a minus 1 quantity squared. Correct, children? Oh, can I do now cancellation, guys? This and this. This and this. This and this. Oh, what else? No more. Okay, so we have 2 times, there is still 1a, no? Cancel a here, minus 1 the exponent. Get it, guys? Guys, the denominator is what? Yan. Patinin nyo yung mama nyo o kaya papa nyo para pag meron kayong homework, ma-assist kayo. Oo. Guys. My children. O kaya yung mga kuya nyo. Okay? Pero wag lang sa test, of course. Number 5. Get it, children, guys? Children. Last one here. Before we go to complex fractions, the last part. I think I have a class in. I will just continue the recordings. You may now leave because I have another makeup class in other section. Guys.
Okay po, sir. Thank you.
Okay. Thank you. I will just record the other part.